really helps you focus. So even though I'm going to put up my notes, I would recommend that you write down too, because that otherwise you're going to get bored and your mind is going to be drifting somewhere else, and you're going to be looking at your phone and yes, I do know I have kids, and I know what sometimes they do when they are listening to the professor, their classes. They are actually also surfing the net and doing a bunch of other stuff. That's why I'm recommend that if you're going to spend 50 minutes, why not get the most out of it. So write down when I'm writing, because I talk to, so you're definitely going to have time to write down. And later on, when you look at my notes, it may not make that much sense. Your notes will make more sense to you than my notes. Okay, so in relational databases, the files have a predefined structure. And the last thing, and this is very important, is that database is all about retrieving data and getting information. So the data are organized for efficient retrieval. So, so I would say that these are, just keep this in mind, that for a relational databases, these are the three motivational, fact. They are related, they're predefined structure, and they're organized. So I just want to give a very simple example, just really simple. So let's say, so I give this, a typical Facebook kind of setup. So I'm just going to write down this example. Rose is 16. And she's friends with Matt, who is 15. Joe is 17. Matt, Joe, and Sam are friends. So suppose, there's like a, this information is given, and then there are a bunch of queries. So these are the queries that you're going to ask. Who are Joe's friends? List the 16-year-olds who has 14-year-old friends, or who has friends who are 14-year-olds. So I have this example, and sorry, I have this example, and these are these three queries. And so this is such a 3-line example. And if I asked you, you'll have to scan and say, okay, who are Joe's friends? And you kind of read through all this and say, okay, Joe is 17, Matt, Joe, and Sam are friends. Okay, so Joe's friends are Matt and Sam, but it takes a considerable amount of, even just for us, it takes a bit of an effort. And in databases, you're going to look at huge amounts of data like this, and you have to answer such queries very easily. So a way of doing this would be to put them in files. So in this case, let's say I have 2 files, and file number 1, I have name, and I keep age. And I write down, I have Rose, who is 16. I have Matt, who is 15. I have Joe. Okay, so if I have this kind of file, it's very easy to answer questions like who lists the 16-year-olds yep, there's Rose who's 16. It's so easy to see this and you got it. But this from this one, I can't figure out who are Joe's friends. I can't answer that query. So we have another file where we keep name and we keep the names of the friends. Okay, so we have Rose and we have Matt. We have Matt. And we can write all of them. And Matt has two friends, Joe and Sam, but in databases, it's easier if you put just one piece of information everywhere for retrieval and all. So I'm going to keep it like that. And then we have Joe, where's Matt? Okay, so we have this information. Now with this information, it's very easy to answer. So who are Joe's friends? You can look at it and say, okay, Joe has Matt and Sam has their friends, who has 14-year-old friends. Okay, now when we look at the question, who has 14-year-old friends, then you have to you have to join. You'll have to bring somehow age into it. And that's the only way you can answer this question. So you have to join two tables. So that's the thing. Another thing with databases, when you look, so if you look at it, so that's, remember I mentioned that databases, they are related tables. So that's what I meant by related tables. When you have databases, and you will rarely find a table that is not connected. In fact, if you have a table that is not connected to at least one other table, then your database design is not good. You will find that in databases, if you pick, there is every table in some way or the other is connected to other tables. So these are all related tables, and you will be able to answer the queries. And so oh, another thing out here, I just, if you notice, I have Matt, his friends, Joe and Sam, but I also have that Rose's friend is Matt. Not typically, I mean, you would say that if Rose's friend is Matt, then Matt is also Rose's friend. What is the chances that you have a friend and that person isn't your friend? I mean, then that's not really your friend. I don't talk about the Facebook friends, but so another good thing about databases is that if you said that if Rose is Matt's friend, then Matt is Rose's friend. If you can actually specify that in the database metadata. So then if you added just this piece of information and didn't add the other piece of information, the database will tell you there's an error. They'll kind of flag it. So for something like this, you would have to add this last thing about Matt and Rose. So it kind of will force you to, do this, to add this to the table. So it kind of helps you out in that manner, so that so that there are fewer data entry errors. I mean, things like that, humans can make mistakes, the computer, I mean, the databases will prevent that. So another thing, so these are all files. So I do want to say that in databases, they are really referred to, these files are really called tables or relation. In databases terminology, these are called tables or relations. So I have two relations out here, or two tables. It's just database terminology. Another thing is, you might ask, why are there two files? If, for example, this last query, who has 14-year-old friends, I have to connect these two tables. So the question is, why do you have two tables? Why not just have one table? So that's another topic that we'll talk about. It's called normalization. So I do want to mention that I may not be saying anything right now, but we will talk about why there are two files. Why not 1? And so that will come under a topic called normalization. Okay, so I hope everyone's got an idea of what relational databases are by just this one simple example, if you have a general idea of how that's going to go about. Uh, so then the next thing so again, like I mentioned, just jump in if you have questions. So if nobody is jumping in, I'm just going to move on. So what is the difference? Because so far you've been writing programs, and I'm almost certain that other than this very first initial program where you do hello world, almost most programs that you write are taking some input data. And if you have large amounts of input data, you are taking them from files. And then you're doing something with the data. That's what all programs do really, is take in some data, do some kind of calculations, and output some data. So how is a file approach different um, from a database approach? So what is the file versus data approach to data management? So, or what I'm trying to say is that how is a database different from data files used by your program? Um, because all your programs are using files. So the main thing is that, whenever you have used have you ever, I mean, you must have, if not explicitly noticed, you've noticed that whenever you change your input, whenever you change your file, um, all your program has to be changed and recompiled. Everything will, the moment you change anything, yeah, all the application programs are going to get affected. um, that's what happens in file base. But in database, you could change on the back end, you could change the database structure, but you don't have to recompile all your programs. Almost all your SQL queries will work just the way they did earlier. So that's one of the big things, is that you are kind of separating data from the application program. While so far in everything else, your data and application programs are closely embedded. You can't separate. Now you can separate the two. So I would say that that would be the, so. So that is a huge downside for file-based approach, but in a database, that's not the case. In a database, you kind of separate the two. So you're decoupling. Um, Another thing about databases is that when you have files, all that you have are the files, is data in the files. But in a database, you store not only the data, but you also store information about the structure of the file. So you're storing both data and metadata in a database. So by metadata, I mean the definition about the data, what the structure of the file is. So data definition. But in file-based, you are not storing any of the metadata in there. The metadata is all in your program, the way you access your program, right? So in a relational database, that's not the case. So another thing with databases is that so in addition to the database, the database, that is the data, the metadata, they also store information about how to efficiently retrieve the data. So let me just, so that's in a database. So that's something we're going to talk about. I'm sure that you haven't, I mean, you're coming out of 515 anyway, that is a backend for this. You heard about indexes. Um, indexes, just like an index for a textbook, if if you want to find, like, for example, you want to read about, so in a database book, you want to read about, say, the select command, you would go down into the index, look up which page select is, and then just go back. So indexes, it's the same thing in these databases. It's all about retrieving information. So in order to retrieve quickly, you need indexes. Um, um, I think you've done B-tree indexes and all in 515, so you know about indexes. So the thing with databases are that these indexes are stored along with in the database, and they're managed by the databases. And the great thing about indexes is that, remember that database is all about storing files that are huge, massive files. So when you do programs, you're looking at small files, and if you want to do a sort, you load the entire file's data into main memory, right? And then you do the sort. What would you do if you could not load the entire data into main memory? Most of your programs will fail. So, if only part of your data could come up and you had to kind of sort the program, you'd have to write a program that deals with it. It's a lot more difficult than just having all the data in main memory. Now you're talking about databases. There's so much of data. You can't load all the data into main memory. That's not going to fit into main memory. On the other hand, indexes fit into main memory. So that's the big advantage of having indexes, is that the entire index will fit into main memory. So that is why it's called efficient, because it fits into main memory. Okay, so, and then another thing with relational databases is that there is a language for querying and building the database. And that's the one you're going to be studying in this class. So that's the SQL that we are going to be learning for relational database. That stands for structured query language. And it's very different from, let's say Java or C, or Go or Python, because all of those languages are procedural. You would have to write down. So if you want to retrieve data from a file, you have to write everything on how to retrieve, open the file, read so and so, and then, so you have to write all that stuff down. But in SQL, it's a very, it's, you just have to say what you want to do. So it's a very functional language. So you don't have to explain how to do it. It's a non-procedural language. So it's very, very simple. It's very English-like. It's, yeah, I mean, we'll be doing SQL, and you'll find that it's so easy to do things in SQL. So, so that's another thing with databases, is that you also have a language relational database to do queries. Then there are other things. These were some of the main points. Um, I mean, if there's a crash on the computer, the database will handle it. So these are all, I would say, secondary. I would say the first the earlier ones were the main, but I just want to write down if there are computer crashes, then the database will handle it. You don't, as an application programmer, the programmer does not have to deal with the computer crashing. You don't have to write code to deal with it. For example, you know, uh, right, just I was just before, I mean, yesterday I was just sitting and writing a program to do map reduce. And, it's, so there is a master and worker. And if the workers die, then you have to put up other workers. So my program has to deal with all of that stuff. When things crash, everything the programmer is doing. But in a database, if anything happens, anything goes wrong, you as an application programmer does not have to do anything at all. The database will take care of it. So you don't have to worry about that. Other things that you can deal with, so these are all things I'll talk about, is that uh, things like, sometimes there is redundancy in the data, and the same information is stored in multiple files. So you have to keep the data consistent. So things like that are also handled by the database. So, and these are things I'll talk about in more detail later. So data consistency. And all of this are handled by that. So for example, when I'm saying consistency, it's like when I remember I said in that example that Rose was Matt's friend, then you have to add the information that Matt is Joe's friend. Or if I said that Joe is married to Rose, then Rose is also married to Joe, so things like that, you can think of those as consistency. And so those are things that even if a programmer does not have to deal with it, the database will handle it. Then there are things like data security and concurrent access of data. So all of that will be handled by the database. So the main thing about database, I would say, is that it allows applications to be independent of the data. So I would say that would be the main thing, is that independent of data, it's to some degree, when I'm saying, but what I really mean is that it allows, things like data definition. I would say this is what I meant by data. So things like data definition, the storage end, all the management issues, all of that is handled, you as an application programmer does not have to deal with any of that. So is there any questions here? So, I mean, so the whole thing, like I said, is the database is never really about SQL, and it's not really about, it's really about just the data. It's a philosophy, it's all about the data. The data is the most important thing. So I do want to say, the word data is supposed to be plural, but in database management, we always talk about it as a singular. So I would, instead of saying data are redundant, I'm going to say data is persistent, not data are persistent. So I just want to make sure that it's not a grammatical error when I use is. In database, we talk about data as singular. So So the data is persistent. It's more important than the programs that access and manage the data. So and another thing is that data is large. So we are talking about large, gigabyte, no, terabytes of data. So when data is large, it cannot be loaded into main memory. So you cannot ever, the assumption is that when you're working with databases that the data is so large, it will not fit in main memory. So okay, so when you talk about database systems, I mean that it means it includes both the database plus the database management system, the DBMS, um, uh, and the DBMS that, when it's a database management system, usually database, they mean just the files, the database. The DBMS is all the programs that allow you to query. I mean, just want to separate that. So that's that allow the user to create. So for MySQL, for in this class, we are going to be using MySQL or MySQL. I don't, whichever way you want to call it. I'm not sure. I think either one is correct. Uh, so so we have Oracle's, of course, is very one of the most popular ones. And then you have IBM's, you have Microsoft. So for this class, I'm going to be using MySQL. It's an open source. So that's the thing, for other classes, you all have accounts and agate. So here, of course, you have accounts and agate, but the system administrators, they are very wary of allowing students to have access to databases via the web, because they think that's a security problem. So they're scared on agate if you're going to work with databases and you want to do web access of the database, that it's very easy for hackers to hack into agate, and they're very scared about that happening. So for this class, you're going to get accounts on Basalt. So you have by default accounts on agate, but when you start working with SQL, it's all going to be on a different machine called Basalt that is only really used for this class because it's easier for hackers to get into a system through databases. So I just want to say that when you start working with SQL, you're going to be working on a different machine called Basalt. And at some point, I will put out information about Basalt online. So besides relational databases is going to be 10, there are other data models, and I just want to, and in this class, if possible, I will touch on them. So there's XML, which is a hierarchical system. And so there is also not, no SQL really means not only SQL. That means that these systems will also have other stuff besides SQL. So in all of these cases, unlike relational databases, which are very structured, these are all very semi-structured. Or unstructured data. I think Professor Diaz, she does in her class, she really works with unstructured data, text documents. So we have those two, completely unstructured. So I would say it's 10:01. So I'm going to stop now, but I'll continue with this in the next class. But the main thing I do want to say, the difference between relational and other models is that in relational, it's really like a schema on write. When you write the schema, the database design is set. In all these other databases, it's when you read, you try to define the schema. So anyway, I'm sorry I went over the time. So I'll see you on Wednesday. And if you have any questions, I have office hours immediately following this. You can just show up on my Zoom office hours. So bye, everyone.
Bye.